Good evening, everyone. Welcome to NPTEL tutorial session for the course Classics in Total Synthesis, taken by Professor Krishna P. Kaliappan, Department of Chemistry, IIT Bombay. And I am Sri Lakshmi S, a PhD scholar under the guidance of Professor Krishna P. Kaliappan in the Department of Chemistry, IIT Bombay. So far we have been discussing around 12 lectures were there in total for this course Classics in Total Synthesis. So we had already a 12 tutorial sessions, and in all those tutorial sessions we have been discussing the basic content discussed in that week's lecture, along with the detailed mechanisms of the reactions which might not be familiar with for you, or which might be familiar for you, and you may be getting a revision for those. And we have discussed several questions related to those topics discussed in the lecture, and we solved assignment questions. So in the last class we have been discussing the week 11 assignment. So this was the last question which we discussed in last week's assignment. So moving on to the next question, identify the major product formed in the reaction given below. So here, this compound, upon treatment with this tertiary butyl hydroperoxide in potassium hydride using THF as solvent at minus 20 degrees Celsius, out of these four options given here, which can be the major product formed in this reaction? So from these options, it is clear that an epoxide is forming. That is, one of those alkene is getting converted into epoxide. So you just have to identify, like here are three alkenes. So selectively, which alkene can be converted into the corresponding epoxide by this tertiary butyl hydroperoxide, and which would be the relative stereochemistry of that epoxide, whether it would be above or below. Although this is a racemic compound, we can only specify the relative stereochemistry and not the absolute stereochemistry. So the options are also according to that, according to the regiochemistry and the stereoselectivity of the epoxide formation. So try to identify which would be the major product. So here, as we can see, this compound could be written in this format, and as we can see, when we write it in this format, this alkene, this exocyclic alkene, is more feasible as compared to two of this endocyclic alkene. So this can again reversibly exist in this form as well, which is kind of a twist boat, we can say. So when this is a more favorable form as compared to this form which is given in the question. So if we consider this form, we can see this double bond, maybe we think this is more accessible, but when it is written here in this format, this double bond is more accessible as compared to this and this. And here also, since this epoxide will be forming from the above face. If we consider this as a like 3D format, or in a model structure, if we consider this, we can see that this double bond is more approachable for the formation of epoxide from the above side. So below side also it is forming, and we will be getting a 4:1 mixture of epoxide diastereomers, but the major would be the one with the above stereochemistry. So the correct answer would be option A. Now moving to the second eighth question of week 11 assignment, identify the major product in the following transformation. So again, this compound upon treatment with this KH and 18 crown 6 in THF at 60 degrees Celsius. So some ring expansion is happening. So which rearrangement it is and what can happen and which of this product can form. So try to identify the major product which will be formed in this reaction using potassium hydride and 18 crown 6 reflux condition. So here what is happening? This kind of a ring expansion reaction is happening here. So this this bond will attack over this position, this double bond will shift over here, and this bond will break, and this will come over here to form this compound. So basically what is happening, this KH will take this hydroxy proton, so this lone pair of oxygen will, or that negative charge will come, that will fall over here, then this fall over here. So this OH will be converted into this corresponding ketone, and then this bond will be breaking to form an alkene over here, and this double bond will attack over here, and this will come over here to form this compound. So the correct answer would be option C. Moving to the next question of week 11 assignment, identify the major product of the following reaction. So here this particular aldehyde, upon treatment with this boron species with 4 angstrom molecular sieves in toluene at minus 70 degrees Celsius, which will be the major product formed here out of the four options. So here what is happening, this is a type of aldol reaction we can say. So what will happen, this, so here this center is attacking over this position, and this double bond will shift over here, and this group will leave to form this particular compound. So the correct answer here is option A. Now, so moving to the last question of week 11 assignment. Identify the major product in the below reaction. So this particular compound upon treatment with this benzaldehyde in KHMDS at using THF solvent at 0 degrees Celsius, which will be the major product here. So four options are given, so which can form in this reaction. So here what will happen, this KHMDS will abstract proton from this hydroxyl group, and this O minus will attack at this carbonyl carbon center of this benzaldehyde, and that will go here, and then that can attack at this double bond to form this compound. So the correct answer is this oxygen lone pairs which will attack at this double bond, and that will be quenched to form this compound. So the correct answer is option D. Now moving on to a discussion about the last week lecture content. So in the last week, the first lecture was about epothelons by Nicolo. The first two lecture was about epothelon total synthesis, and then we have seen vancomycin B2 total synthesis and saragassic acid total synthesis. So coming to this epothelon, we have seen in the first lecture application of olefin metathesis and Yamaguchi macrolactonization approach respectively in the two different total synthesis of epothelon A by Nicolo's group. So this natural product epothelon was isolated in 1996, and it shows exceptional anti-cancer activities. And this was isolated from the Myxobacterium sorangium cellulosum strain 90 with novel molecular architecture, important biological properties, and an intriguing mechanism of action. Nicolo's total synthesis of epothelon A, which was published in 1997, utilized an olefin metathesis approach. This total synthesis reported by Nicolos demonstrates the power of olefin metathesis reaction in the complex molecule construction and renders epothelon A readily accessible. It is a flexible route towards total synthesis of epothelon A. The ring closing metathesis allows synthesis of 5 up to 30 membered cyclic alkenes. In the case of olefin metathesis, a 2 plus 2 cycloaddition occurs between the metal alkylidene and the olefin substrate to produce a metallocyclobutane intermediate. Retrocycloaddition then occurs to afford a new metal alkylidene and the olefin metathesis product. And the key reactions involves aldol reaction, esterification, olefin metathesis, epoxidation. The total synthesis was accomplished from three different fragments that could be synthesized from commercially available starting materials. And Nicolos group synthesized this compound in 11 steps with 6.7% of overall heat. Then they came up with a macrolactonization approach where a rapid and mild esterification method using 2,4,6 trichlorobenzoic carboxylic anhydride as the anhydride counterpart for the preparation of large ring lactone from corresponding open chain hydroxy acids. So this is Yamaguchi's macrolactonization. And in this approach, key steps involves where aldol reaction, macrolactonization, Wittig reaction, and epoxidation. An alternative approach that relies on a macrolactonization process for constructing the main ring skeleton of epithelon A was reported by Niccolo in the same year 1997. This is a highly convergent and practical synthesis of anti-tumor agent epithelon A, and this total synthesis was completed in 18 steps with 5% of overall yield. Now, epithelon's synthesis was also reported by Shinser and Danishevsky's group. So, there we have seen in this lecture 56 the application of stereoselective aldol reaction in the total synthesis of epithelon A by Shinser group and Suzuki coupling and macrolactonization in the total synthesis of epithelon by Danishevsky. So, in the Shinser's total synthesis of epithelon A, we have seen a convergent total synthesis of minus epithelon A, which was achieved using a flexible and efficient route. The asymmetric synthesis of three key fragments have been achieved in a straightforward way. And the key step in their new approach is the stereoselective aldol reaction. This was also completed in 1997 in 16 steps with 2.58% of overall yield. Then in Danishevsky's synthesis of minus epithelon A, which was completed in 1996, this was the first total synthesis of epithelon A reported by Danishevsky, and the key steps involved were Suzuki coupling and macroaldolization. And this total synthesis was accomplished in longest linear steps of 20 steps starting from commercially available R-glucidol with an overall yield of 2.64%. Now moving on to this vineomycin on B2. So here in this total synthesis, we have seen the application of heterodielsaldar reaction and Claisen rearrangement in the total synthesis of vineomycin on B2 methyl ester by Danishevsky and Negishi, and Suzuki coupling in the total synthesis of vineomycin on B2 by Tears group. So vineomycins are isolated from the culture broth of an actinomycete designated as Streptomyces matensis vineus from Takada in the Niigata prefecture of Japan. All of the vineomycins are active against gram-positive bacteria and against sarcoma 180 solid tumors in mice. So Danishevsky et al. Reported the total synthesis of vineomycin on B2 methyl ester in 1984 using heterodielsaldar reactions key steps. And the starting material used was methyl crotonate and juglone, and the key reactions involves heterodielsaldar reaction. And they completed this total synthesis in 11 linear steps with 9.1% overall yield by Danishevsky. And in TS total synthesis of vineomycin on B2, here this vineomycin on B2 methyl ester is derived from the acid catalyzed methanolysis of vineomycin B2, and the total synthesis of vineomycin B2 reported by Marcus and co-workers in 1991. A general method for appending C glycosyl units into anthraquinones and anthracene have been described and can be used for the preparation of the diverse C glycosides. The synthesis starts from a commercially available 1,8-dihydroxy anthraquinone. The key steps involve Stille and Negishi coupling reactions, and they completed this total synthesis in 11 linear steps with a 4.6% of overall yield. And the last lecture of this course, or this last lecture of this classics in total synthesis, was about uh, Saragozic acid. And there we have seen the application of Evans asymmetric aldol reaction and Peterson olefination in the total synthesis of plus Saragozic acid by Carrera group. So, saragossic acids and squalestains are a family of naturally occurring fungal metabolites, independently isolated and characterized by researchers at Merck and Glaxo. So, these natural products are potent inhibitors of squalene synthase and have potential as therapeutic agents for the treatment of hypercholesterolemia. All the saragossic acids and squalestatins have a common 2,8 diaza-bicyclo-3,2,1 octane core with an array of six stereogenic centers including contiguous quaternary carbon atoms and are different only at alkyl and acyl side chains at C1 and C6 respectively. So this saragossic acid A was extracted from sterile fungal culture Spormilla intermediate, while saragossic acids B and C were isolated from a fungal strain identified as Leptodontium elateus. The saragossic acids A, B, and C exhibit potent inhibitory activity toward rat liver squalene synthesis with apparent Ki values from 29 to 78 picomolar. So, Carrera et al. Reported the first asymmetric synthesis of the potent squalene synthase inhibitor plus saragossic acid in 1995. The synthesis allows for the preparation of multigram quantities of dioxabicyclooctane core common to all members of this class of fungal metabolites. And they use the starting material D-erythrone gamma lactone and they completed this in 25 steps with 4.1 percentage of overall yield. So that was about the lecture content. I will give you a couple of minutes to just quickly go through the last week lecture contents. Then we will move towards the discussion on week 12 assignment. So now moving on to the week 12 assignment. So for the first question is identify the major product formed in the following transformation. So this particular compound upon treatment with this. I will just give the animations to the answer so that we can have a better discussion maybe. Okay. So the first question is identify the major product formed in the following transformation. So this particular compound upon treatment with NHMDS, methyl iodide and THF, then in the second step with LAH and diethyl ether, which will be the major product here. So here the correct answer is, firstly what will happen, this NHMDS will abstract proton from this center, and that will attack on this methyl group of this methyl iodide to form this one. So here this stereo selectivity is controlled by this chiral auxiliary. Then in the next step, this LAH will reduce this chiral auxiliary. So this amide will be reduced and here alcohol will be coming. So the correct answer here would be option B. Moving to the second question, what is the major product formed in the following transformation? So this particular compounds, this one and this one, upon treating with LDA and THF in the first step and in the second step with PPTS and methanol, which will be the major product out of this four options given here. So here what has happened, this LDA will abstract proton from this sender and that will attack over this aldehyde, this carbon to form this compound. Then PPTS and methanol will deprotect the sustenite protection of this diol to form this compound. So the correct answer here would be option C. Moving to the next question, identify the major product in the following transformation. So this particular compound upon treatment with this EtCOCl in the first step and then hydrolysis in the second step, which will be the major product here. So here what is happening, this EtCOCl will form this ammonium salt, chloride salt of this particular amine. So this will be in iminium ion form and this Cl minus will be existing as the salt form. Then upon hydrolysis, this whole group will go and this ring will be opening and we will be getting this particular aldehyde. So the correct answer here would be option B. Moving to the fourth question, identify the, sorry, here answer is given. Identify the right sequence of reagents that will result in the transformation given below. So this particular compound is converted into this diol, so which will be the corresponding sequence of this reaction? Either first methyl vitic, then dibyl H, and then this oxidation, or dibyl H, then oxidation, then methyl vitic, or this oxidation, methyl vitic, dibyl H, or dibyl H, methyl vitic, oxidation. So here the correct sequence of reaction is, firstly this particular compound, this alcohol is oxidized using this pyrrhic Doring oxidation and to get this aldehyde, followed by this methyl-Wittig olefination to get this alkene. Then this dival H will deprotect both the spivallyl esters to give this diol. So here the correct answer would be option C, first oxidation, then methyl-Wittig, and then dival H reduction for the deprotection of the pivallyl ester groups. So the correct answer would be option C. Moving to the next question, identify the major product of the following transformation. So this particular compound upon treatment with LDA, HMPA and the silyl bromide, which would be the major product out of this four options? So here the correct answer is option C. And what is happening? This methyl crotonate, from here this proton abstraction take place and that bond will shift over here. This will come over here, and then to that negative charge will go and attack over this position. This double bond will shift over here and this will go. So here this position, like a 1 4 attack kind of thing is happening. So this position it is attacking over this group. Not that position, this position. So this proton abstraction will take place from this methyl group. This will shift over here, and this double bond, this position is attacking over here, and this will shift to here, and Br minus will leave to give this compound in 51 percentage of field. So the correct answer would be option C. Moving to the sixth question of the assignment, identify the major product formed in the following transformation. So, this particular aromatic compound, upon treatment with this rhodium trichloride in ethanol and then heating it in the second step with this diethylamine, which would be the major product here. So, this is a two-step reaction. In the first step, the compound is being treated with this rhodium trichloride in ethanol, and the second step, it is like whatever product was obtained, it is heating with this diethylamine. So, which will be the major product here? So here, what would happen? Firstly, with this rhodium chloride, what is happening? This double bond isomerization is taking place, and this exocyclic this external double bond is isomerizing to this internal double bond, and we will get this product. Then it is heated upon this to 210 degrees Celsius. This 3,3 sigma tropic rearrangement is happening. So to form this compound, so here the correct answer would be option D. Moving to the next question, identify the major product formed in the reaction given below. So this particular compound, upon treatment with this HCl methanol, we will be getting a product which is given in this four options. One of the product, one of the options. So which is the correct answer for this question? So here what would happen, and in the presence of this HCl methanol, this hydroxyl group will attack over the center and it will form the cyclized structure. So the correct answer here would be option A. Moving to the next question, identify the major product in the following transformation. So, this particular compound upon treatment with this NABH4 in IPA, which will be the major product here? So here the correct answer would be the NABH4 will reduce both of this uh, ketones, and that will be converted into the corresponding alcohol. Then it will be eliminated so that we will be getting an aromatized compound. And so the correct answer would be option A. Moving to the next question, identify the major product of the following reaction. So this compound upon treatment with this trimethyl aluminum and NaIO4, which will be the major product here? So here the correct answer is this one. So this trimethyl aluminum, one of the methyl groups will attack over this epoxide. Epoxide ring will open to form this compound, and then NaO4 will cleave this diol to form this aldehyde. So the correct answer is option D. Now moving on to the last question of this week 12 assignment. Identify the major product in the below reaction. So this diol, upon treatment with this dimethylamine in methanol, uh, and in the second step with this orthoester kind of derivative in the presence of paratoluene sulfonic acid, which will be the major product here. So here the correct answer is this one. So this dimethylamine will attack over this center and it will open this compound to form this here also aldehyde, and here this vainrabamide kind of compound, not exactly vainrabamide, but then this orthoformate will protect this diol in the presence of this paratoluene sulfonic acid to get this compound. So the correct answer here would be option B. So with this, we are concluding our tutorial session for this course Classics in Total Synthesis. So far, we have taken around 12, uh, 12 plus 1, 13 tutorial sessions in total, and all these videos will be, link will be provided to you, and the slides also you will be getting. So thank you for all your time through this time, and thank you for listening, and thank you for joining. So hope you had a good time of discussion with for this course classics in total synthesis. Thank you.